Hello everyone, Chris here, Solutions Architect at IP Fabric, and today we're going to be talking about observability. Most organizations are investing heavily in the term observability today, whether it's logs, random metrics, net flow information, all being collected into a singular place, and they're trying to get insights about their infrastructure. There is a critical piece that I think is missing today, and it is some of the feature sets that IP Fabric offers. Today, we're going to talk about how an end-to-end flow inside of IP Fabric can help out with observability and how IP Fabric has a unique way to think about observing the network. Most modern day observability platforms, they stop at the edge of the network. Your application performance monitoring system might say your application is having issues. Your log system, your SIM might say the backend is healthy. NetFlow is showing you might have some traffic issues, but there's no actual concrete evidence of what the issue is. So come in with that end-to-end flow from IP Fabric, and you'll be able to quickly see where in the network you might be having issues. How does IP Fabric do this? We're going to take snapshots of your network, and you're going to be able to reference different moments in time and gain the context as to why the network might be having an issue. What we're looking at here, given a source and destination IP address, IP Fabric can map the entire flow that this source and destination IP address is taking. You can see every element in the network here. I can zoom in. We can move these elements around. Here we can see light blue represents layer 2 connections, pink represents layer 3, yellow or orange might represent MPLS or IPsec, and we come back down layer 3 to layer 2 to the end. Now you'll notice there are some red firewalls here in the middle. This is indicating that traffic is being blocked by a zone firewall policy or an ACL or some type of security mechanism. We'll also notice there's a green router here, and this indicates that there might be like a PBR issue or maybe an ACL on a router that's blocking traffic. I can right click anywhere along this path and press explore. You'll get taken to this inspector that I have here down at the bottom, what we call the path inspector. You can actually see the packet's headers and how they would have looked as information is traversing these firewall interfaces. And here in the middle, I can see all the security decisions that need to be made for this packet in order to move on to the next hop. So if there was an adding applied, we would have seen it here. We can see there was a route table match on this firewall. But more importantly, we see there's a zone firewall policy blocking traffic. I can click on the name of that zone firewall policy and actually see this is a default deny that's denying traffic. And on the left side of my screen here, we can see the actual settings that I'm using for this path lookup. So we're testing out TCP port 5432, and traffic's being denied by the default deny. Now, if 5432, the port used in this path lookup, is a critical port for a critical application, meaning maybe Postgres database runs on port 5432, so this could represent a critical application path that is now being blocked somewhere in the network. This level of observability that you get hasn't really been available using modern network monitoring systems, right? These network monitoring systems don't necessarily have the ability to tell you why a packet is making its decision to move to the next hop. Because you have this information available to you, you can now make a decision intuitively whether to add a new zone firewall policy rule to this firewall to allow traffic, or if you should modify an existing policy. Moving on to the next part of the path, we actually see there's another firewall blocking traffic. Just another increased amount of observability you gain by utilizing IP Fabric to see that there's indeed two firewalls, not just one, that could be blocking traffic here. Another core piece of observability when it comes to IP Fabric is the ability to see that these paths indeed change over time. Traditional observability tools are generally lacking, right, that ability to see any type of flow that you see on the screen here. IP Fabric is a snapshot-based solution, so being able to move back in time as we collect new snapshot information gives you the ability to see how these paths may have changed over time, right? So here we can see this path indeed change between 2 days. I have two snapshots here, one that represents pre-change, one that represents post-change. And we can see the path completely changes between these two snapshot days, right? We can see there might have been suboptimal path selection. Maybe this green router over here was performing PBR or policy-based routing, and we don't want it to. So pre-change, the path looks like this. Post-change, the path looks like this. And we can actually compare that right in the UI and show the delta between two moments in time. When people are complaining that the network might be an issue, actually having the documentation and proof that the network is changing and paths are selecting the appropriate ways to go across the network, really does help expedite that troubleshooting process, that proof process, that mean time to resolution. It decreases those metrics by just giving you the access to network information that traditionally has been non-existent, right? Those network monitoring systems do not give you the clarity that IP Fabric gives you in this simple view. To quickly touch on more how IP Fabric relates to observability, just taking a quick look at our dashboard here. IP Fabric collects thousands of data points, hundreds of columns, hundreds of tables, and we're able to organize the results of this data and give you advanced insights into it. I don't want to spend too much time on what these data points represent. The point that I want to make is you have the ability to organize them into specific elements that prove the certain posture of your network infrastructure. So if you have PCI compliance, maybe as an example here, we know on the IP fabric side what elements we want to check in the network that relate to PCI. So PCI requires to have specific logging enabled, AAA settings, SNMP configured correctly. So what you see down here is this health assessment of how your PCI environment is properly configured to prove compliancy, right? So your security posture matches the compliance you're telling your customers. If you're processing payments, you have to have these settings enabled. If you don't, you could be in violation of certain compliancy metrics, and that's going to be a problem for whatever organization we're talking about here. When it comes to observability in IP Fabric, another critical part of that is access to information in general. What makes IP Fabric unique is this ability to be vendor agnostic and capture critical data points about your network infrastructure and give you a simplified view into those data points. If I go over here to the addressing managed IPv4 table, here we can see every single interface that is configured in my network, which IP address is assigned to it, which network it's a part of. It doesn't matter if this is a Cisco, Arista, a Juniper, a FortiGate, an HP device. It doesn't matter what vendor or what platform that operating system is running. We're able to normalize this data into a single view and give you insights into how your entire network is configured. Now, as organizations scale, complexity grows. So most organizations are moving away from a single vendor solution in their network. And this requires them to have tools in their environment that are vendor agnostic. So IP Fabric supports a lot of different vendors here. You can actually see on this table here all the different vendors that IP Fabric supports, plus the operating systems that are supported as well. And again, we give you that normalized view into that information. So whether you're looking for, again, all the IP addresses and what interface they belong to, you could be thinking here, how do I update my IPAM records from data from the network? This is exactly the table that you would use in that scenario. Or it could be what VLANs are configured in my network and where they are configured. It could also be, a unified route table so I can see all the routes in my environment, regardless of vendor, and query them the same way a network engineer would query a route table traditionally on a router CLI. So this allows, again, moving back into that observability conversation, this allows you to gain insight and access into a normalized data structure that traditionally most network monitoring systems do not give. If you want to hear more, please contact your IP Fabric representative, whether it's your solutions architect or your account manager, and we'll be happy to inform you.